It is now time to have a look at Shader Graph, which is a artist tool that permits you to create shaders. Back in the days, it wasn't that easy to create shader. You'll see it's quite simple now, but you had to write HLSL code, which stands for High Level Shader Language, or I'm not sure what the other one was. Well, it's not as complicated as it used to be. So to try this out today, we're going to go through the shader graph, and I'll actually create a folder inside of artwork, or maybe just outside of assets completely, and I will call it rendering. I will then right click on rendering, create shader, and then we'll have to look at the second section over here. The five first are regarding the old ways of creating shader. It still works today. You can actually create shader like that, but it's going to be really hard to make work with the universal rendering pipeline. In the meantime, these five over here are built for shader graph, you could say. 2D renderer is really for creating 2D shaders. In this case, our game is not 2D, so we're not interested in that. Unlit would give you a master node that has nothing to do with lighting. It stands for physically based rendering, which is a really, if you're trying to create something that is very photorealistic, that's the one you would take. But let's have a look quickly, because I just want to make sure you understand what goes on behind these. If you are to create a unlit, and if you are to create a PBR, the only difference you'll see is that the master node, so the product in the middle, is going to be PBR master, and for the unlit, it's going to be unlit master. So really, these are just settings that will change the master node. But for today, we are going to create a PBR graph. You might be thinking, hey, we're not creating something that is very photorealistic, but we're still going to be creating something that has lighting in it. So I'd like to go ahead and create a PBR graph if we feel like it's a little bit better to go with no lighting whatsoever. So if we don't like the shadows and we don't like anything else that has to do with that and the light, then we could go ahead and switch to a different master node. But for the moment, and as we're only testing shader graph today, let's go ahead and create a PBR graph, and I'll call it shader test. Okay, now it's very important that when you do create a shader and you want to test it out, this now becomes a shader inside of your material shader list, which means if I want to use this on, for example, this igloo, I will have to right-click rendering, create myself a new material, and I can call this one the same name, so shader test. It doesn't have to be the same name, that's just like a preference that I have. And then we're gonna head at the top here, go under, where is our, oh, here it is, so shader graph. And we are going to use our shader test. Now I have this one, I can drag and drop it right on top of the igloo. And now this igloo now uses our shader test graph. Okay, let's give it a look. Let's double click on this one and see what happened. The object is actually being rendered using this PBR master node. And you'll see on the left-hand side over here and on the right-hand side, these over here are basically inputs. So it's rendering with a certain amount of alpha, a certain amount of occlusion, metallic, emission, normal, albedo, all that kind of good stuff. Now, just to see the changes as we are changing them over here, as we do some changes here, just to see them, I'll actually move my camera, so this one, I'll move it to see the igloo in a nice frame for my game window, so what we see here on the left-hand side. It's going to be a way to work that is going to be a little bit more efficient. Okay, so this igloo right now, being rendered by this exactly. If we just click somewhere and we decide, hey, you know the albedo, I want it to be on like bright blue like that, and hit Save Asset, you'll see that this changes color. And that's because the albedo now has something different. You can play around with that as much as you wish. But that's not really the point today. We're trying to figure out what to do with this shader graph. So the next thing we will do is try to figure out how this window works a little bit better. You'll find at the top left over here, this is what we call the blackboard. So you can toggle it on and off just by clicking blackboard at the top right side. We also have the main preview, which is down here. Main preview is self-explanatory, really. So if you change something, you'll see the change happen directly on this object. And also do note that you can rotate it around, which is really hard to see right now because we only have one color. And you can also change it to a different model, so capsule, a quad, or even a custom mesh if you wish. So we can see rendering being done to this thing. Now, what is really cool is the blackboard at the top hand side here. This blackboard will let us actually use inputs, so different type of inputs for our shader. And I'll give you a quick preview of that. In case we would like to specify the color directly here, because that's the case for some other shader. If you're trying to do a normal standard shader, let's do URP lit, you'll have a lot of input over here. You can say, hey, actually my base map is this, it's that, it's all of these. You actually choose specifically for this material. And you could have another material called shader test 2 that uses a different texture. So now I'll go back and I'll show you how to do that. So the inputs are actually being done through the blackboard over here. So I could decide, hey, let's add a new color, for example. And that color is going to be the base color of our mesh. Now, if we save this asset, you'll see at the top hand side over here that we have a setting. And this is for my material. So I say, hey, my base color is actually the full alpha yellow. And I hit save. Actually, I don't need to hit save because that's shader material here. But you're going to realize that still, even though I've defined a base color, I'm still rendering with this red. And that's because the red is the one that is connected to the PBR master. And now we have to find a way to say, hey, I want this color, the base color, to be put right here in the albedo. We can do that by actually click and dragging this right inside of the graph. And now we end up with two different nodes. And I can say, hey, I'm going to connect this one with the albedo by just clicking here and dragging this all the way there. And you're going to realize that base color is actually 4 and albedo is 3. Albedo is only looking for RGB, but base color has RBGA, so it has alpha on top of it. But it's still going to work just fine. So now if I am to save this, it's actually going to render with the color that I specify here. So this is all done, not through this window, the small window we had here, but through the material, which means, if you remember, if I am to create a new material, call it shader test, say number 2, shader test 2, and apply it to, for example, this tree in the background. It uses the exact same thing, so the exact same shader graph, shader test. We now have two different material that uses the same shader and has different color because of that. So this is actually how we go ahead and we input a parameter. Now, before we close this off, I'd like to actually show you how to go around and work with this window in maybe a little bit of more efficient manner. Some of the keybind you can use is just like the clipboard. So I can do Control C for copy and paste the base color. I can do Control C for cut and paste it somewhere else. I can press on F while I have a node selected to focus on it. And the most important keybind, the one you like the most, is just pressing on spacebar, and it's going to give you the list of nodes you can create. And there is quite a lot of nodes you can create. So for example, the one over here, it's called base color. It's actually a property. I can find it under property, and the only one we have is base color. So we could have created it this way instead. You're going to realize you can play with a lot of different things. For example, I could say I can create a checkerboard, and you know what? That will be my albedo instead. Now we end up with this type of result, which is really not that good because my UV all collapsed. Now what would be the best thing to do here is actually delete, for example, the base color and go with a texture 2D instead and just call it main texture, for example. I can drag and drop it here, put it under the albedo. Oh. Actually, you cannot put it directly like that. You have to go through another object. Another way to create a dialog window just like this to create a node is just by clicking somewhere and then releasing it really in the blackboard. which is going to let you, for example, do an input texture, and you can sample a normal texture. And I'm going to output the RGB into the albedo, which now means whatever the texture we define here is going to be put directly under the albedo. So I need my atlas, and we are back. And now, just like that, we are back to a very basic, just apply the texture to my mesh type of deal. Some of the things that are maybe interesting to look at is that every time you have a node like this, on the left-hand side, you will find input parameters, which means you can modify what the texture is in this case. You can have different sampler, and on the output, you can actually say, hey, this is where the blue is, and this is where the red is. You can like output a single channel. For example, one thing that I just did is that I made sure to drag and drop my texture in the default, not because it's really useful, you can always change it anywhere, but just because it gives me a preview directly here. And what I wanted to say is that on the right-hand side over here is the settings you can actually export from whatever texture you have. So here, you can export the RGBA, which stands for red, green, blue, and then the alpha channel of this texture. All of them together is going to give you a vector 4, and we're putting that vector 4 inside of albedo 3, which means we're actually not using the last one. So alpha is right here, and it can be put anywhere you wish. So if you had a little bit of transparency, you could put it directly here in alpha. You'll see that we really don't have that here. But if we are to use another icon, for example, this one has transparency, we hit save. It doesn't do anything, but that's simply because our PBR master is not configured to do transparent. If we click on the small gear at the top, then we could actually switch this to say, hey, we would like to have a transparent surface. And then we end up with really weird results. So we'd have to play around with it quite a lot to make it work in our favor to have alpha. But that's not the goal for today. So we did a very quick overview of everything, really. I'm going to put it back on something normal so we have a nice starting point for the next video. And with this, we are now going to dive in even deeper to create ourselves a shader that modifies the actual vertex value. So it changes the vertex position. Simple reason is we'd like to bend the world. So this input over here is going to help us bend the world. All right, I'll see you then. So previously, we created a shader test, a graph, a material, two material, in fact, and we just played around with the shader, that is. So what we plan on doing today is actually start creating our real shader that is going to be used throughout the whole game. It's a technique that you might want to do for optimization, but in case it's not possible to put everything under a same shader, then of course having one more doesn't really hurt you that much. But it's some good practice. Just like how we put all the objects under this one texture over here, we can also do that for shader, and that's what we intend to do for this mobile game. So without further ado, I'm actually going to remove everything that we've created in the last episode. So 1, 2, 3, everything in the rendering folder is going to go. And we'll see that these two objects, they lost reference. That's simply because, of course, they're attached to a material that no longer exists. So I'm going to go ahead, right-click on rendering, create myself a new shader, PBR shader. I feel like calling it Atlas or main Atlas. Actually, I'll just call it main. Yeah, that sounds a little bit better because we're going to be using more than one material outside of this. One of them is going to be for the snow on the floor as well. So I'll just call this one main. And let's go ahead and just produce a simple shader that we can apply to everything else. So here is what we'll do. We're going to go and create a new texture 2D at the top here, and it's going to be the main texture. I'll make sure to drag and drop this right in here, and we are going to put that in a sampler 2D. So sampler 2D. And it will look something like this. I'm going to go ahead and also put the default texture so we can do a little bit of previewing as we work. And let's just drag and drop this in the albedo. And just like that, already we should have recreated what we had previously. So we have a shader called main, and it just puts the texture on top of the objects. And since that is the case, I'm going to go ahead and just make sure that everything in this scene actually uses the same shader. So I can see that my objects right here, it's actually using Atlas texture So where is this one actually? Let's try and find this one. I'm going to right click on it, select material, and it's under the model, environment, material, and atlas texture. Now, once I'm on there, I'm going to go ahead and change the shader to use the one we just created. So shader graph main. And you'll see that since we plugged in our main texture, it didn't change much. It's actually very, very similar. And I'll make sure to actually drag and drop this on top of the igloo and also on top of the tree as well. Now, one more thing. I also want to change the snow material to use our shader because we said everything should be under the same shader. Let's right click, select this material. I'll go down here and I'll make sure to change it to main as well. But of course, the main texture in this case is going to be the snow. Now we do get one problem. So we're gonna run to the first problem that comes with this. This is our snow material, and we're gonna have a couple of things that are gonna be scaled up and maybe scaled down. And you'll see that if we'd like to have like the snow look a little bit better or a little bit more detailed, we'll need to scale down the object as well. And that's not really cool because usually what happens with a shader like this, a typical shader like this, if we go under lit, it gives you the option to actually do tiling and offset. So if you'd like to have more detail, you can just style it. And that's exactly what we're going to go and add to our shader. So quickly, I'll put that back on main. And we're going to go under our shader once more. And over here, this means we'll have to play with the UVs. Now, there is something called tiling and offset actually. So we can go ahead and just hit spacebar, tiling and offset. So it takes three different parameters, a tiling, and also an offset. So it's exactly as we just seen under the different shaders, the actual general purpose one. And of course, it outs it. So let's go ahead and add it just like this, see what happens. You're going to see that nothing really changed. And if we were to play with the offset a bit, you are going to run into this type of trouble. Now I've offset everything and we have some weird color. Obviously, offset might not be what we want to do here. Actually, it is not what we want to do here. But if we are to tile, you're going to realize that we're affecting much more than just the snow. So this means this object right here, the tiling, is going to have to be an outside parameter. So it can change depending on which material it is. So it can be unique to its own material. So I'll go ahead, create a new vector one. Vector one stands for a single value, in fact, and we'll call it tiling. I'll drag and drop this here, put it under the tiling. I'm actually tiling in both X and Y at the same time. I didn't plan on using two-dimension tiling, but if you want to do that, then of course you can just create yourself a vector 2 instead. And I can also create myself another one for the offset and just drag it just down there. Okay. Now with this in mind, we can now save once more. Oh, we're having some type of issue here. So the tiling was actually 1, 1 earlier, so I can put that on default 1, save it, and it doesn't seem to work. What about the offset? Okay, so it feels like even though we've saved it as a default parameter, it didn't actually add it down here. So it's going to be very important to go back and change it to 1. And now you'll see that even if we do this, we move the offset, it's going to work great for the snow. So we can get a better offset. Actually, you can move that snow as well if you like it to move. You can do all of that on this very specific material and not actually move the offset for the rest of the material, which gives you a really weird effect, actually. Now, one thing you might realize, and might not be the case on your end, but it might be, is that if we tile a little bit too far, we actually reach the end of the texture, and then it's always going to be this color. So you see the number going up on the right-hand side, but we always reach the same color, which simply means we're at the end of the texture. And if you'd like that to not happen, actually, you can select your texture in your import settings and make sure it's actually put on, we can do repeat. So the atlas texture would not scale up, would not actually go beyond that point. But as you can see now, it repeats itself. So we're going to have infinite color. And yeah, it just looked very, very weird. But at one point we start seeing that. So that's that for this texture, but I do not need it for the atlas. I actually don't need it to repeat, so I'll just put it on clamp. However, you're going to realize that it is actually set on repeat for the snow, and that's why this one didn't have this problem. You can actually tile it as much as you want. That being said, we're actually done with the albedo part of this shader, so you can say the easiest part is actually done. I'm going to go ahead and put a tiling of 5 on the snow, and let's call it a day. In the next one, we'll start playing around with the vertex position. Now it is time we move away from albedo, which is where we were for the color, and we move on to the vertex position. By changing the vertex position, you'll see that there will be an offset on every single pixel you see here. There will be an offset to what it's actually going to be rendered at. So let me give you a very quick example. If we are to just take the object space, that's the default, so that's where it is being placed within the scene, and then we change that, for example, for vector 3, 0, like so, then all the objects are going to be put at the same space. So all the object using this very specific shader, all the vertices are now standing at the world position, the world 0, 0, 0, which obviously, if all the vertices are actually on top of each other, we're not going to see any triangles. They're just going to be all crashed down like within here. It is also good to note that even though we will see them technically appear over here, you can still select them the same way as you would normally. So it does not change the collider. It does not change where the pixels are in the scene. It just changes them where you see, it just changes them visually, you could say. So to go a little bit further with that example, with a better, actually a better example, by default, it's actually using the object space. So let's go back into object space, or I believe in this case, it's position. So the node is called position, and the space will use object space. So technically, if we are to just go here and override, press save, this is what we had prior. This is actually, now to be a little bit more clear with my example, what I'd like to do is actually do a little bit of arithmetic on this position. So let's modify it before it reaches this point. What we could do is add them together. So we could do add position with another vector 3 that we defined manually. Now you're going to see here that the inputs are actually 1, 1. But if you go and you drag this here, it's actually going to give you a modified version of that node where it's now 3, 3. And if you were to drag a vector 4, you would have the 4, 4 as well. So sometimes it's worth just dragging this on top of the node and see if it actually takes it. So for example, we are going to say, hey, all the vertices, yep, put them all together here. So that's my vertex position. Put them in the first one. And also add a vector 0, 1, 0. So technically, if we are to drag the add over here, put it there, every vertex we see are going to be incremented by 1. And now you can notice that every single object, they had the same position as they had prior, but now they're rendering. So only the rendering part is always 1 meter higher in Y. Okay, so we know how to modify that. That's not so cool. Let's do something a little bit more fun, right? So let's go ahead and add something that changes over time, such as time. So if I go over here and I input time in the search, we have a couple of options. For example, we have sin, costs, and also just the overall time. If we are to just modify, for example, the y with the sin time, sin being a wave, we are going to see quite a fun behavior. So you can see it over here happening in the preview. And let's save. And we get this kind of result. Now, if you're not moving the scene at all, if you're not moving the camera, it's not going to be rendered. But of course, if we press play, it should be very, very smooth. So let's give this a look. And now our game is technically breathing. Okay, so we've played around with this a little bit. Now it's time to go and try to curve the world. So our game is being played on the z-axis. I'd like the z-axis to be curved over time. So here is what I'll do next. I'll take my floor. Actually, I'll go ahead and I'll modify this so it just sends in the normal object position as of right now. I will take my floor and duplicate it a couple of times in the z-axis because that's the one we would like to curve. If you're wondering, I copied using Control C, Control V, and then I'm moving around with Control toggled in, so it locks into the axis and it gives me snapped values. Okay, so we had a good idea a little bit earlier where we would take the position that it's currently in, and then we would add something. So I'll recreate the same exact small layout we've had because that's actually quite important. We are going to be taking just an offset in Y, just like we did earlier, but we'll have to calculate it in a better way. So what's going to end up happening is we are going to calculate how far away we are from the camera. And then depending on the distance in between the camera, so this vision I have right here, and say, for example, that pixel, we will take that in the z-axis, and then we'll actually increment what we currently have, so this position, with a certain y value. So it goes a little bit higher. But that will all depend on the camera. So just putting my note back on this. So it's very important to remember that what we're doing here, these two nodes together, are just setting you up so we can reuse the object position. We can reuse what the values are here. Because if we are to set straight values without going through this, then we're not adding on top of where they are in the scene. We're just setting their values directly. Okay. That being said, we need to calculate something regarding the camera position and also the world position of the object. So we'll need two new nodes. First, position, but instead of using the object space, we will be using the absolute world, and we will need also the camera node. Now, camera gives you a couple of things. We are interested in the position. Now, I want you to imagine this as 3D objects in your scene, because we're using the absolute world values and we're using the we're using these values so they behave just like objects in your scene. So when we say camera position 3, we are looking at these number here, so the position number. And when we're saying the absolute world position of, for example, this floor, we're talking about 0, 0, 10 in this case. So let's actually take these nodes and subtract them. So we will go ahead and create ourselves a node called subtract. And we'll make sure we take the destination minus the position, which means this one minus the camera position. Or I did that wrong, yeah. And then we're going to take the camera position and remove the actual position of the vertex. So if you're getting confused, we can swap them around like so. And this will give us the distance in vector 3 in between the vertex we're trying to modify this frame and also the position of the camera. But we don't actually need anything else but just the z value in this case. So what we could do is put it through a split. It's called split. It's basically if you were to create a new vector 3 and you want to split it in different ways. So we have x, y, and z. And we're only interested in z. So now we have that z value. We can put it through another node. So I'll just move this a little bit towards the left. So what we're interested in here is the difference in z. So that's distance in terms of our game. So we go in the z-axis. We run towards the z-axis. So we'd like to know how far away this is from the camera. But what we're going to be modifying is not the z, actually. We're not going to be pushing objects further away. Instead, we are going to be taking the z and we'll be modifying the y. So that means I'm actually going to create a vector 3 and I'll say, hey, your z, put it in the y, like so. If you're getting confused here because we're having a vector 4, it's really up to you. You can have vector 4 here as well. It might be a little bit easier to understand. So that z goes into the y. And then, you know what? Let's just add it, see what happens. I'm going to save the asset. Oof, and we're getting kind of the behavior we'd like, but it's just it's very linear and it's very weird to look at. So the further we get away from the object, the higher they are, and that's exactly what we'd like to have as a behavior. But obviously, This is not going to cut it for our game. We don't want to have something that is super linear, so we have to go back and do some arithmetic. So the next thing I'd like to address is the linear. So you see how this just goes in a linear fashion. It just goes from a higher value always in the same manner. I'd like to have a smooth curve, so having more of a quadratic equation in there. So what we could do is we could split them apart right around here. And before I put it inside of the vector 4, I'm going to go in here and do a power. So we could do a power of 2. I'll drag and drop this right here. I actually don't need to have such a big preview for power, so I'll collapse it. Then I'll use this for the y. Or actually, because this is going to give us a very, very big number very fast. Yep. um, I'm also going to multiply it by such a small amount that it's not going to be that bad. So let's do multiply next. And we're going to do power goes right here. And multiply output goes in the y-axis. And I'll just move this a little bit better. We never have enough space when we're doing this initially. But now in terms of the power, it'd be good to have some way to control the intensity of this. So what I'll do is I'll open up the blackboard and I'll create a new vector one called curvature. And by default, I'm going to put a very small value. So for example, 00 and then 1 after the digit. Drag it here, and here we go. Hit save. It's already getting a lot better. So if we just move away, we'll see that it goes up like so. But it doesn't go up all at the same time, which is what bothers me right now. But just to give it a look very, very quickly, I will take, for example, this snow. Just up the curvature, see what kind of result we get. And we have to up it very, very slowly. But in terms of the axis, this is a smoother curve, so that's quite fun. Yep, much better. And we'll have to multiply this by a transformation matrix that is going to flip the normals. And we can do that by going here, transformation matrix, and getting the out like so. I went ahead and I've saved it, and I'm just going to up the curve on the snow shader, but also on the atlas shader. And then we end up with something like this, which is actually what we want. Now, it might be hard to play around in the scene with this because, like, for example, this igloo is over here, but we see it at the top there. But when we go ahead and we play our game, we are going to run, and it's going to look like this. Oh, I always go beneath the world, as you can see. But if I were to angle a bit better, you always stay right on top of the surface. Which also lead us to see that our player is clearly not being affected by this shader. So let's select him and let's make sure he has the proper shader. And here he is. So I've just applied the Atlas texture material to the penguin, and now he is right there. Well, physically he's right there, but visually he's right there. Okay, so that is how we just bended the world. And if you are to create a bigger environment, you'll see it much clearer than we do right now. But as we go through this game, as we walk forward, the world just comes down, and then we can do our action, and everything beyond that point just goes up. And that's pretty much it. So I'll see you guys in the next one. Welcome to the third section, which is the final section before we get into coding, finally. In this section, we're going to make sure we can build this game, this pretty much small scene, onto our device, and we will be using an Android device. Now, if you are using iOS, I do plan on making another version of this video, but it's going to be under the optional. So look for iOS build, how to build with iOS lesson under this very specific section, so under section number 3. And now for the Android folks, we're going to be using the route in which we use the Unity built-in SDK, and also in the optional, there's going to be an optional regarding the manual install of the SDK. So if you're using the Android SDK from their website and you want to build it using the manual approach, but Unity actually gives us, with the new installs, it gives us a really good way to just build to Android without even having to worry. So I format my computer every now and then, every maybe 10 days or so, and I don't even need to install the Android SDK anymore. I just install Unity and I build to my phone directly. So let's have a look at what it gives us. Um, for this example, I'll make sure to go and install a new version of Unity, but if you followed the tutorial earlier, you should have the Android build support, which is right here. And I believe we are on point 2, so this is the version we're using right here. We can see add module, and we can make sure that we select these two. That is what we'll need for the Android. So in case you don't have that and you'd like to move to the LTS, you can just click here and make sure those are toggled in. I also made sure to include iOS support, but if you are planning on building to to Android only, don't put it. It's quite a big download, so I wouldn't put it in there if you wish not to build to iOS. So um, if you made sure that you have these, so the module, you can now close this off. To make sure we have these installed, you can just have a look under your version and look for the module, or you could also go, and I encourage you to do that, to edit, preferences, and external tool. If you scroll down at the bottom here, JDK installed with Unity, Android SDK tool installed with Unity, the NDK installed with Unity, and also Gradle. So everything here installed with Unity. If you have verified that you have all of these, then it's time to move on to the next video in which we will configure the game to actually be published to an iOS or Android device. Now, before you publish to mobile, you have a couple of things you have to prepare. And the first thing I'd like you to do is go under File, Build Setting, and switch over to iOS or Android. So we will click here and make sure we can switch platform. This will not show up if you didn't install the Android build support. So make sure you have that. We did that in the previous episode if you don't remember how. Just make sure you switch. It's going to take a little bit of time. So after a little bit, the engine should have re-imported everything. Now what I do suggest you do is if you're going to be building to portrait, which is what we'll do, is to switch your game aspect over here. So your aspect resolution, I would switch it for something like 2560 by 1440, which is going to give us this ratio in which we can start modeling our game around. So this is going to be like the portrait mode. I'm also going to move my camera over to see the penguin since he's the only one in there that has an animation. And by doing that, when I do boot this on my phone, I'll be seeing something that moves at least, so it doesn't look like it's frozen. By the way, if you're curious what I'm doing right now, I'm holding Control Shift and F while having camera selected, which is going to place it at the location I was. So Control Shift and F to move it like so. Okay. Next up, we're going to go under File, Build Settings, and then we're back on Android, but now select Player Settings on the right-hand side, and you'll see that this pops up. So this is the project settings window, and it's very important that we fill in as much information as we can in there. The name of the company, in this case, is going to be the Epitome Games, which is, you can put anything, really. Product name is going to work for me. The product version 0.1 is good. And you can decide to put a icon for your game. If you're not putting anything, it's going to put in the Unity default icon. Now, going down here, you'll see that you have the icon setting, and these icon setting are just for overrides. So if you are to parse this in the 16 by 16, you can actually change that. But if, for example, you'd like to have a bigger icon when it's being displayed on, say, a iPad, and you'd like to have a different smaller icon, you can check override and actually change any of these if you wish. So maybe it's your full character here in the 1024 by 1024, but once we go to a smaller scale, maybe it's just his face or something. So keep making sure you are under Android and not PC or iOS in this case. Next up, we have the resolution and presentation. It's going to differ in between the different types, so that's why I want to make sure that we're all on Android. Over here, I'm going to uncheck everything but portrait. So when I play the game, it doesn't want to switch rotation in the middle. So if I tilt my phone on one side, it doesn't actually switch. You can also set a default orientation of portrait. It's going to disable everything else. Show loading indicator, I actually don't like doing that. You can put it in there if you wish. It's just a matter of something you see while the game is loading, but usually it's very, very fast and you barely see it. The splash image has to do with once you boot the game, you're going to see a Made with Unity logo, but then you can also have your own logo on top of that if you wish. Or if you played for Unity Pro, you can disable this altogether. Now, here is where it gets interesting. So under the other setting, we are going to change quite a couple of things in here. We're going to start with the color space. We have the linear and also gamma space. Since we're building for mobile, I do recommend we switch over to gamma like I just did. So if you are to do that, you're going to see a little bit of time before it reimports all your texture. We can work on making our game looks a little bit better, but it's something that is important to do at the beginning. We're quite at the beginning still, so we're not too late. So let's keep looking. Multi-threaded rendering, we would like to have that, of course. Static batching as well. Compute scaling, yes. I will be skipping over the light maps because we're not using any. And I'll also skip the frame timing stats since we're not doing any kind of debug for the moment. So most of the time when you go through this menu, you can get nice explanation on what the settings are if you just mouse over. And Vulkan, we are not going to be using Vulkan. What we really want to modify is over here under the identification. So this section over here usually goes like this: COM, the name of your company, and the name of your product. And it's actually going to be very important that you remember this because this is what is going to be the unique identifier for your app worldwide. So if I try to push a game with this package name under my phone, and then I go on another computer and I have the same package name for a different game, they are going to be overridden. So the first game, even though it's something else completely, if I'm using the same package name, the first one will be overridden. So it's very, very important that you have a unique product name for every time you have a new package. This one will do for me. So that being said, I'm actually glad because before they didn't set it automatically, but it seems like now they actually do it. So this one is good. 0.1 is the good version, and we also have a bundle version code. I want you to be aware that every time that we're going to be making updates to our game, once it's published on the Google Play Store, we will need to increment this every time because Google will not accept a package that has the same version or the same code version as a previous one. So if you're to make an update, you have to increment this by, say, 0.1. And the code version has to increment by 1 as well, at the minimum. So for our case, we're not on Google Play Store just yet, so this will do. Now for the scripting backend, I'll switch that over to L2CPP, and that's because we will need the 2 architecture for Google Play. It's now a new requirement that requires you to have the 64-bit as well as the 32. So I'll make sure to click on ARM64 once I have IL2CPP enabled. This is also very recent from Google Play, and we have to comply. And we can then move over to the publishing settings. This is something we will leave for a little bit further down the road. And the simple reason here is because we're still making the application, we're still debugging the application. We don't intend to put it on Google Play as of right now. We need to complete the whole code and we have to make sure everything looks good before we do that. But once we do, this is where we'll decide, hey, we're ready to put it on the Google Play Store and we need to have some sort of way to lock it to us. So using a key store, we can you can see that some kind of SSH file where only us have access to the key store and we have to input a password to sign our application. And once our application is signed, then Google Play will know that it is us that is making an update and we can actually update this game. So just a quick story. If you are to sell your application to someone in the future, you'll have to provide them, yes, with the Google Play account that hosts it, but also with the Google, the key store. And also the password that goes with your product. And finally, we have the XR settings, which stands for the AR and VR. No plan of doing that within this course, at least. So we can leave it as is. And our game is now ready to be built on phones.
Hey guys, this episode we're going to be looking at pushing to our phone, but we have to prepare this phone before we push to it. If you just buy it off the shelf right now, you will not be able to push your Unity build to that phone right away. We need to do some little bit of setup first. So I have my Pixel device here. You should be seeing it on the screen. And what I'm going to do is I'm going to not do that. I'm going to pull my window here at the top until I enter my device settings. So what's going to be important for you is to enter the device setting in here. For this very specific phone, it would be clicking the gear. So this could be at different places. I know that if you have a Samsung device, it's not located exactly the same place that this one is. So just make sure you go ahead and you look for your settings. If you don't know, please go ahead and just Google it. What you have to do next is scroll at the very bottom all the way over to the About Phone section. So this one right here. I'm going to click on it. And with that said, skip all this information and go at the very bottom once again. And you're going to tap, double tap, triple tap. You're going to keep on tapping this button here that says Build Number. Now, for me, I already have my developer mode enabled, so it doesn't do anything. It just keeps telling me that I don't need to do that. I'm already a developer. So, but for you, if it's the first time that you do this, you are going to unlock the developer mode for your phone. So now you can go back one step. At the very top here, I'll be looking for developer option. So there's a search bar. I'm just going to input that here. Go under developer option. And then I'm going to have to scroll down all the way until I see USB debugging. And it's going to be very important that we enable this. So that is what is going to allow us to push build to our phone. So having the USB debugging enabled. So once this is completed, all you will have to do now is hook this in your computer, the one that you're having Unity on, build, and then you'll realize that the first time you build over, it's going to ask you if you allow this very specific computer to push stuff onto your device. You're going to say yes, and then just right after that, you're going to have a build on your phone. And that's all you have to do. So I'll see you guys in the next section. Cheers.